Welcome to Cash Up, a weekly show where we converse with amazing folks in DFIR. And today I'm so excited to be joined by Dr. Eric Katz. Eric's been in the field of digital forensics for over a decade, conducting research and creating methodologies that enhance our discipline. He's currently a senior cybersecurity engineer for MITRE, where he's worked for nearly 11 years. Previously, Eric was an instructor teaching cyber forensics courses at the undergraduate and graduate levels, as well as the law enforcement coordinator at Purdue University. In addition, he's done internships with both the Lafayette Police Department and the Indiana State Police. Dr. Katz earned his PhD in cyber forensics from Purdue University, where his dissertation focused on using machine learning to detect changes to stored device data. Eric's research has been published in multiple of conferences, including at the American Academy of Forensic Sciences, AAFS, the Annual Information Security Symposium, the International Conference on Digital Forensics and Cybercrime, with work published in the Journal of Forensic Sciences and more. His digital forensics research includes involvement with the Safer Viewing platform and periodic mobile forensics. I remember the first time I met Eric at the Regional Computer Forensics Group, RCFG conference in Virginia. And when he said his name, I was like, wait, you're the person who wrote a field test of mobile phone shielding devices. And we've been kindred spirits ever since. I feel like Eric is the person you always run into at DEF CON and brings a smile in a sea of being around just other too many people. And I am so happy to be joined by Eric today. And with that, hi, Eric.
Hello. It's good to
How
be
you doing?
I'm doing well.
Thank you so much for coming on today. I'm a big fan of your work, and you've done some really cool things. I think you're our first PhD guest, so that's not that we don't have others planned. But how did you get here? How did you get into doing all of this great forensics research and really coming up with all of these shifting methodologies?
It was a long road. In high school, I knew I wanted to do something with computers, but I didn't know what it was. And all the fields for computers were still relatively new. And so I went to IU, to college, and I was like, all right, what's here? I'm going to major in computer science because that sounds really computery. I don't know anything about it, but I'm going to do this. And I had a really bad experience.
Oh.
Yeah. I just didn't get along. I think maybe it was my first class was like Java, which to this day I'm still not a huge fan of. But I didn't like it and I withdrew.
Oh.
Yeah. Who would have thought I'd withdraw from college? But then I started an associate's degree in electrical technology. Went back to get my bachelor's in informatics.
Huh.
And while I was there, informatics was my first academic introduction to computer security. And I had a minor in criminal justice just because that interested me. And while I can't remember most of my professors, I will remember Steve DeBroda, who was at the time the U.S. Assistant Attorney General for Southern Indiana, and he was responsible for all cybercrime. So he was the professor for the one and only cybercrime course that IU offered at the time.
And what year is this? Because IU having a cybercrime course at that time seems pretty innovative.
Yeah, I thought so. That would have had to have been like 2005, 2006.
Wow. Yeah, that is early
really
for.
But I remember being fascinated, not only with like what cybercrime was, but how the investigations happened. And I was like, this is what I needed to do. And so I asked him, the professor, what should I do to follow up? And he recommended I apply to Purdue for their cybercrime and computer forensics program, which I had never heard of. But I was like, all right, I'll do that. And then by the end of the semester, he had a practical exam. And we had to write a report on our investigation and what we did and what our conclusions were. And while I can't remember what I said, he was impressed enough with it that he recommended me for an internship with the Indiana State Police.
Oh, awesome.
So that summer I became the first intern the Indiana State Police had in their cybercrimes unit, which was really fun because I got to learn and work with detectives, but at the same time, we had to figure out how to tiptoe around, like what cases can I work on, what am I allowed to do and not allowed to do as an intern since I'm not a sworn officer.
Right.
It was the first time they ever had to deal with that type of information, so I got to see that. But it looked really good on my resume, and I got accepted to Purdue shortly after my internship ended. And that's when I started my master's program with Dr. Rogers and Rick Mislam, both excellent professors. And I did 4 years there. Technically 5 years to get my master's. Took a while to get my thesis written. But the first course was the Intro to Cyber Forensics course with Dr. Rogers, and that was just eye-opening. So much information to absorb. I ended up becoming the TA for that course, which led me to becoming the law enforcement coordinator as well. And so as a TA, I had to update the course because a semester cannot go by without everything changing.
No, I can't go. I teach as well, and I can't go a single week without updating the next week's lecture because everything changes so quickly. Yeah.
Yeah.
100.
So I was responsible for that, and then I was responsible for Purdue used to teach law enforcement courses, digital forensics, how to be a first responder type classes for law enforcement all over the country and all over the world, actually, which was a lot of fun. And eventually I started teaching the courses, not just the law enforcement one, but teaching the ones at Purdue. And that was a lot of fun. And while I was there and still getting my master's, I was like, I want to do this someday. I want to be a professor. I really enjoyed it, which is why I went to get a PhD after I finished my master's program. It was never my original intention to get a PhD, but I enjoyed it, and I was like, in the future, this will be useful. So while I was still a student, I decided to finish up the coursework that was required, read another dissertation on top of my master's thesis, and I got there.
Which is awesome. Congratulations again. So then how did you go from having done some internship and light casework, we'll call it that, to get around the sworn officership with the police to doing research in the digital forensics arena for MITRE? And I'm sure everyone is familiar with MITRE, mainly from the attack framework. I've been familiar with MITRE for many years because of forensics work from when I was in other spaces. But how did that happen?
It happened because while I was doing my internships, one of the things Purdue stressed and still does is that you should have hands-on experience. Everything should be practical, not purely intellectual. And so we have internships with the local law enforcement, the Lafayette PD. And then as the law enforcement coordinator, I was working with officers everywhere, either helping them on cases or directing them to somebody who specialized in whatever problem they were having. But we always get weird questions like, this doesn't work, or, so-and-so says you can't do this. And one of those questions was, hey, I see this series of illegal images, but I only get a thumbnail because they're in this shadow volume. What's the shadow volume and how do I access it? Well, that was right after Windows 7 came out. Nobody knew what they were or how to use them.
Yeah.
And according to Microsoft, they were unrecoverable at the time.
We laugh because we're all recovering volume shadow copies, remounting them, and dealing with all that data now. So it's,
yep.
I would say that is one of the key things in forensics, and I've seen this in documentation from Microsoft, Apple, etc. Sometimes there are assertions in there, and people take them as ground truth. Test those assertions. I have found things that have contradicted vendor documentation many a time just because I said, really? Let's test that.
That's where a lot of my research comes from. Is the really? Are you sure about this?
Really?
So Katie Strimka and I, one of my colleagues at the time, figured out how to recover those shadow volume copies, and we published a paper. I want to say that was at AAFS, and that's where Dave Baker saw me and read it and offered me an internship like as soon as I left the podium.
That's awesome.
Which was fantastic. And yeah, that's how I got into MITRE and learned that this was a research company, and like that's the type of thing they do.
Yeah, it's really cool. I love two things here. One, I love that you have this academic background that's really suitable for research, but that a lot of what Purdue stressed, and that you consistently were doing internships and working with and in labs, actually conducting investigations, because when academia isn't tied to that practical component, we miss the boat. And I think it's so important that we inform each other, that the research and the future drives the way investigations are being done, and that investigations and the true problems that officers are encountering drive the research. And I love that. There was a great talk at DFRWS by Dr. Eugene Spafford, also from Purdue, about like the science, the engineering, and the technician, and how that works in the world of digital forensics, and how all three are imperative, that we have all three levels occurring. And, it sounds like in a lot of ways you bridge all three of those areas. And I think that that's really cool. So you mentioned, you inferred the safer viewing platform that you've been working on, which I remember the first time I saw it, I think was 2018 at DFRWS. Corey showed it to me. A bunch of people, he had it during a poster session. And I think it's an incredible technology to help with officer wellness. Can you share a little bit about that tech?
Oh, absolutely. And I want to give full credit to that team that Corey built.
Corey built an amazing team.
Yeah.
Corey Hall is who I'm referring to, by the way, at MITRE, who is fantastic.
So, and this comes again from that law enforcement grounding. We support many different sponsors, and several of our sponsors had reported that the burnout rate of their investigators was really high, especially when it came to child assault.
Child sexual abuse material, CSAM.
Yeah, like it's just a rough field to be in, especially when you have to deal with that. And so we wanted to know if there was a way we could make this easier for them. I can't really say better, but easier for them and less traumatic. And so we got a bunch of machine learning experts. I was in there as part of the pipelining and forensic process, and making sure all the data ended up in the right place and was attributed correctly. But yeah, the idea was we would take a collection, some sort of image, usually a hard drive or a phone, whatever the case may be, whatever's required, and put all the images and videos through this pipeline that would detect all the faces. It would attempt to do age. We looked at the modern, what at the time was the modern open source available tooling. Look at things like the Yahoo NSFW models and things, and none of them lived up to spec. Like,
they don't. I mean, so we've looked at a lot of those models as well. We've built, where I work on my day job, Magnet, we've built AI for luring and grooming, for child abuse, etc. And we've looked at those models as well. And really, the models, that they don't do what they need to do. I hate to say that about things like the NSFW Yahoo model, but there are improvements to be made, and but I don't think that those models were designed for detecting CSAM. They were developed to find normal things people shouldn't be looking at in the workplace. They weren't looking for noxious content.
No, absolutely, and they weren't looking, like most machine and face detection stuff, it required all the images had to be face forward. So if somebody was sideways, it stopped detecting. So we just had to develop our own models and our own detectors, which was tons of fun, trying to find data libraries. And
the good thing about machine learning is you don't actually have to look at the content to train the machine, right? Yep. The machine can do that without you looking at it. But legally, access to these libraries of data that would contain that kind of content can be a problematic step to take from a legal perspective, right? Even when you're doing it to help law enforcement.
Absolutely. So we did our best with the content we could get, and then once we got the models working, we sent that to law enforcement. We had partnerships with law enforcement where they could run their own data content through and help us. Then we could look at the output and then like refine the model to run again and again.
They were able to help with the training process with their real data sets, their real corpuses.
Yes.
And I know you've also written written papers on data corpuses specifically for these modelings. But having access to real data corpuses and allowing the departments to help with the training, that integration, again, between research and academia and actual law enforcement agencies conducting the work is what betters the industry. So I love this collaboration.
I do too. And after we got the models working, another member was developing the safer viewing platform, as it was, the web front end of it, where we were able to find the portions of pictures and videos that were explicit and kind of gray and blur them out as needed to let you see what's going on in the photo without having to force you to look at all the extreme detail.
So yeah, I think that's really important because when you're using this platform, you can still see faces, you can identify what action is taking place, but the noxious content portion of the imagery is what's blurred. There's a lot of techniques that are used in officer wellness features. I know, like, we've employed in our platform a lot of officer wellness features that do blurring, but they blur the entire image, or, turning off audio or setting timers so that you're not. So officer wellness is very important. I love it. This is new technology that's really focused on using that machine learning to identify the noxious portion of the image and protecting against that. And I think it's brilliant. It's a brilliant way to go that will help help examiners who are dealing with CSAM cases.
Oh, I absolutely agree. I hope it gets adopted by everyone out there, because in the test cases that we've had with officers, I remember when we first started, we had a bunch of grizzled veterans that well, this is just not going to help us. We need to see everything you can't, But after we showed them the platform and how it worked, they were like, I'm less stressed and don't hate life nearly as much. And I've been doing this for 25 years.
Right.
Versus like the new person who's like, well, it's still terrible, but I can go for 4 hours instead of 2.
The context isn't lost, right?
Yeah.
So you still have the context without necessarily having to see the content of the context. And I think that's really, really cool. There was a cool paper presented at DFRWS APAC in January out of Australia regarding the mental health of practitioners who were exposed to child sexual abuse material. And I think that in their explanation of the problem, that this is one of many key solutions to helping. And using technology to help officers is just so critical. I'm so happy that your team has done, the team that you worked with has done so much work on this. And what I also love is that as the project is now recently finished, this is very recent, that it has just recently been distributed to Project Vic, which means that this will be accessible to a multitude of people via licensing to be able to take advantage of the technology. So I think it's really great that that MITRE took a path to sharing it where it can be used by law enforcement through that relationship. It's yet to be integrated, I believe, into anything yet. But again, this is very new. This is hot off the presses, y'all. Hot off the presses.
It's super new. We were thinking like, well, it's great. We're MITRE. MITRE has relationships with like federal law enforcement, and that's great. And we can give them this, but that doesn't help the people who really need help, which is all the local law enforcement worldwide.
The ICAC task forces all over the world.
They're overworked and under under-equipped, and they, my working with law enforcement, there's no way they're going to afford a $5,000 license or something to let somebody hopefully not look at pictures.
That they need to look at, right?
Yeah,
like
exactly.
It's a weird thing to try to position.
So we were trying to think of ways we could make this available to everyone, and Corey found out about Project Vic and was like, we can work with them, and so we licensed the technology through them, and anybody who wants access to it just needs to talk to them. I am not 100% sure on the licensing rules, but if you are law enforcement and you are interested in learning about it, contact Project Vic.
Excellent. So how do you feel, outside of even just the safer viewing platform, how do you feel that the experience that you've had actually conducting investigations has made it easier for you to do research to help people conduct investigations easier? If that makes sense.
Well, it comes back to that grounding. Because I've done the investigation, when somebody complains about something, I understand what it is, or I can develop my own complaints and be like, this doesn't work for me. Why does this not work for me? Or why is this difficult when I feel it should be easy? And so I look into a lot of that. A lot of my research here at MITRE has been like, how do you automate things? How do you process data so that somebody who's not a forensics expert, who hasn't had years and years of education in this, can understand what's happening and present it and make intelligent decisions based off of that.
Yeah, absolutely critical, right? So, I mean, just with the data scales, automation is just something as an industry we need to accept that needs to be done. And I'll also agree with you there that providing content in a format that's appropriate for subject matter experts, not digital forensics examiners, but the content matter experts, is really, really critical. And it's that collaboration, I think, that brings value, right? When the content matter expert can look at the data in a presentable way, say what's important to them, and then the digital forensics examiner can give the attribution, can give the context to the content. We keep talking about context and content, right? Like let the subject matter expert find the content. And oh my gosh, like the number of cases that I've worked in my life that were find bad. It would have been so nice if somebody who had find bad, so you can then give it to the investigator, who then will decide what to do with it, who has more detail about the case, or has intimate knowledge of the techniques or technologies or groups. If they instead are looking at that content first, and then I'm doing the examination based on what I'm going after. Oh my gosh, what a better collaboration, right? This is all about collaboration. So I love that focus.
I love being asked to find all the suspicious things. Here's a hard drive. Find all the suspicious things. I'm like, what's on it? Who's it for? What's this investigation about? So Dr. Rogers always hammered hard on do not operate in a vacuum. Understand what it is you're doing. You need the context. If all you have is content, you will never understand what is actually happening.
So that's really interesting. So your dissertation is not yet published, your PhD dissertation. But I do know that it is focused on machine learning to help identify if there's been manipulation to data on a device. Can you explain a little bit about that? That
absolutely.
Sounds like something fascinating that might help us all.
And actually, since the pandemic happened, I think it might be more appropriate than it ever has been. So as part of my work here at MITRE, we did a project called Periodic Mobile Forensics. And I helped run the experiment at Purdue, where we gave a bunch of students cell phones for a semester, and then we would scan for what data changed on those devices and make forensic recordings of those. And this created a large data set of, I want to say it was 1.5 terabytes roughly of cell phone images, 1,000 something different images of these phones.
I'm gonna pause right there. CFREDS is redoing their entire CFREDS reference set, and they're bringing in other sources. So they're bringing in digital corpora, for example, et cetera. You should get that data set because I believe that data set can be made public, correct? Like if it can, talk to the CFREDS folks because the new CFREDS, they were just talked about this at AAFS last week. The new CFREDS 2.5, I messed around with the beta. It's incredible. So if that data set is possible to be shared, I don't know if it is, that might be a really cool thing. So just an aside.
I would have to talk since it's live human data.
Oh, it is live human data. Well, I didn't know if it was fictitious, but.
Yeah. No, we literally gave students cell phones and told them to have at it.
To use them like they normally would, as themselves. Okay,
yeah,
very cool.
We admit there was some deception. We told them it was a UI experiment. So they had no idea what was going on. All of them, after the end of the experiment, we informed all of them, told them they're allowed to withdraw, drop their data. All the appropriate IRB approved fun facts. And I had to go through 2 different IRBs because I had MITRE's and Purdue's.
I do wonder if the base images could be shared, though. The parts that aren't periodically differentiated. Sorry, I'm on an askew here.
No. I definitely have to talk offline about that.
Yeah, we'll talk offline.
We can do.
There might be something interesting there. I'll connect you with the right people.
Yeah, absolutely. But part of what they did as PMF was they created an intrusion detection system, what I call the traditional way, which they found out all sorts of data about all the users and ran it through, and it was pretty effective. They were like 88% effective at the time.
Oh.
Which is pretty good for a cell phone and what they were working with. But it bothered me because I'm like, well, it's my cell phone. There's all sorts of private information on there. And even if this is a cell phone issued by work, like there's a blend that occurs.
Absolutely.
People don't, especially now in the pandemic age, like the blur between work and life it's a mess. And I don't want Security Joe Bob looking at all my text messages just because an alert came through. And that was what started my dissertation. I wondered, well, with periodic mobile forensics, since we have these images over time and we know what's changed and where, can we just use what's changing where without knowing what that data is? Can we use that to create a user profile? And then can we use that profile to determine when attacks happen, when something malicious is occurring? And so I set about doing that. So my whole data set was literally giant blocks of zeros and ones, whether data changed at this location or didn't change at this location. And I was really excited when I started, and then really nervous as I was learning about machine learning and how this was work. I didn't know if I would get positive results or any results whatsoever. I was hoping for above 50% so I could say I did something. But as I did the experiment and started working with it, I got incredibly accurate results, 93 to 99% accurate, depending on the model and what was happening. So
being able to differentiate between normal user activity,
yes,
which you could discard, and identify anomalous activity that could be potentially indicate some kind of attack, and over a 93% identification rate without ever getting any of the data itself, just by looking at where data location storage has changed and that metadata, and never ever looking at the context. Brilliant. Like the privacy angle on this is what is so beautiful in being able to identify changes. And I think you're right. I think in the current environment, it is even more critical as people are in their home offices, but now they are nodes on the network. Brilliant.
So that was great. I proved that hypothesis. So the next hypothesis was, well, can it detect when malicious activity occurs? And PMF, in its brilliance, and it was not designed for this, but not for my research at least. There are definitely changes I would make to help this particular line of research be better. But one of the things we developed was the ability to push back those forensic images onto the phone. So I could recreate the exact user environment, the same user session that existed when that image was created. And then I would go and run malware or delete files, various things that we considered attacks. And then I'd re-image the phone again, run it through the model, and see what it told me. At that point in time, most of the models failed, but that's only because it was saying, hey, this looks more like the user's data and activity than it does something like a different phone or somebody else, which makes sense. I mean, it was 99.9% the user's activities.
Right.
Everything was exactly the same as if the user had just put it down. But there were a few models that were 90% accurate and more, saying, nope, this is not the user's behavior. You did something different. Even though it didn't know what was different, it knew something was different.
That's all you need to identify.
Blocks were different.
You need to be able to identify which nodes are having issues, right? Like, I'm not saying it's the only thing you need to identify, but it's an amazing first step. And being able to do that so I have a follow-up question for you. So I know last week at AAFS, some folks from MITRE introduced Pablo, which is conceptually periodic mobile forensics, but for disk and other images that are running across networks. So with the next plan, sorry, I'm putting the pieces together here and you're smiling. So it's the next step to then see if this can also apply to disk end nodes.
I would like to see that. I don't know if it will or won't, because
you can't predict the future?
No, not yet. I would love to try it on people's actual laptops and computers and see if they behave the same way as phones. Phones, I know, we're lucky because they're very personal to you as a user. I don't know if people have the same relationship with computers, but I assume they would. And the same things that made the changes in where the data was stored viable are still viable with hard drives. So I would assume that there is some capability there.
If anyone out there is listening is trying to look for a dissertation topic, this may be one.
If you're interested, let me know. I'd be happy to consult and help with that. So once I was detecting these attacks, I was like, cool, what else can I do with it? Turns out, thanks to the machine learning, you can be like, it was these 10 blocks that changed that caused the problem. We don't know what that problem is, but now instead of having to decrypt the entire phone and let somebody look at an entire image and be like, here's 10 megabytes of something. We don't know what it is. Please tell me if you can identify what the problem is. Did the user delete an app? Maybe. Maybe that's what registered. Although, with 30-something students over a course of a semester, I have to assume they were all installing and deleting apps.
Sure.
And so it didn't detect when they deleted apps, but it certainly detected when I went in and changed security.
Oh, wow. That's very fascinating.
I had the feeling a few of my false positives and negatives, because, again, I'm only 90% accurate, probably are things like people installing and deleting apps.
But still, you've now narrowed out all of these non-relevant circumstances and found the relevant. So, exactly. So you're speaking to your false positives. Did you have false negatives? A significant amount of false negatives. I'm in forensics.
Yeah.
False positives aren't that bad, right? Because I want to, as long as I've culled down a lot of data, I rather still see what's there. False negatives are, when we're talking about, we won't get into some of the deeper machine learning topics, but in some of the scoring models, but false negatives, I think, are a larger issue in digital forensics because we can't eliminate exonerable data or potentially dangerous data. So did you have a high number of false negatives?
No, I did not.
Oh, that's pretty cool.
It was more likely to
false positive.
Falsely identify something as a positive than a negative.
Excellent.
On the models that worked.
That's awesome.
The models that...
No. We're speaking to the models that work. Obviously, in your testing, you created a variety of models, but those are not the models that you would move forward with, right?
Correct. And I used both two-tail and one-tail models. So in the two-tail tests, I compared one phone versus a series of images from a bunch of other phones. In the one tail, it was just the phone model, phone images compared to itself. Both were successful. Obviously, the one where it's just the phone to itself was not as good. So there were more false negatives in that. But again, it was a pilot study. We'd never tried this before.
Yeah, no, that's
since
really
identified lots of things that I could change to make it more accurate.
Super, super, super fascinating. And again, what I love about this is it's using machine learning to increase privacy when doing exams. Anyway, let's move on to a different topic here because, I mentioned how the first time I heard your name, I knew who you were because of a paper you'd written. And this is back in 2010. Mm-hmm. And you hadn't even written it as a paper published in a journal. You wrote it as a master's thesis. And I know I'm going back 11 years now, but I want to talk about it because I think it's something that people don't think about. And a lot of us use Faraday enclosures. And what you did was you produced a paper that tested all of the Faraday enclosures that existed at the time, or many of the different Faraday enclosures that existed at the time. But more importantly, you provided a methodology for people to test them themselves. Mm-hmm. And the reason I was so overwhelmed was because I had utilized this to change the methodology we were using to test and validate the security from network, the ability to isolate from the network of the Faraday enclosures we were using. And of course, as your paper demonstrated, some percentage of Faraday bags will fail, right? When you buy a Faraday bag, you are not guaranteed it will pass. What made you start questioning that? Did that come from law enforcement as well?
Absolutely, it did. When I was doing law enforcement training, I think the first time it happened was in New York with the New York State Police. We brought it up and said, this is the standard operating procedure. This is what you're supposed to do. And one of the officers said, well, what do I do if the phone rings while it's in the bag? And we're like, well, it can't do that. It's supposed to cut these off. It's a Faraday cage. It doesn't work.
Like, no, it happens. Yeah.
And we kind of mulled that over and we'll have to get back to you. We don't know what happens when your standard procedure fails. And sure enough, as the next few weeks, a few months, we got more and more stories about that. More officers would complain. And then one day I remember I was teaching a law enforcement course, and sure enough, a phone rang while I was inside one of the Faraday bags. I was just like, okay, we got to do something about this. And so, I was like, well, how can I study this? And I didn't want to go through a route where I was pulling out RF antennas and measuring how much attenuation actually occurred.
I know we were talking about that because I used to work in a lab where I measured attenuation of antennas at the time that I came up to you about this paper. So that's why I was so interested.
I wanted then, and I still want to today, except on good faith that when the manufacturer said this is the attenuation rates, that they are telling 100% true. So I believe that they are being honest and truthful as much as they can
be. Absolutely. But manufacturing errors happen.
Manufacturing errors happen. And just because you've produced something that attenuates to one level doesn't mean that the phone isn't broadcasting at a higher level.
1,000%. And even not to get into some engineering concepts, but even when something attenuates at a specific rate, that's what it's supposed to. There are oscillations. Mm-hmm. So there are actually secondary and tertiary signals that are dispensed by any RF signal. And so it might be blocking the primary, but the secondary or the tertiary can be enough to get through.
Yep. And I was like, all right, well, where am I going to find the strongest source of signal? I was like, you know what? I'm going to find cell towers in the middle of nowhere, where it's the only one for miles around, so we know it's broadcasting at a really high power in order to cover the largest area it can. Luckily, Indiana has lots of those because we have cornfields. And sure enough, if you look, there are cell towers in the middle of cornfields, and it will be the only one covering 10 square miles. I made the mistake of saying, let's do this in November, October, November. So I remember standing in a cornfield where there's no corn and a lot of wind and snow with, 13, 14 different phones and 6 or 7 different Faraday cages, putting the phones in, trying to call them, trying to call out, seeing what would happen. And that was just a simple recording. Like, did it make a connection when it shouldn't?
Right.
Pass, fail. And it really came down to kind of a coin flip as to whether or not the Faraday bag would actually block a call, an incoming call. And that's no good when you have remote wipe options on your evidence.
No, that and it's funny because the reason this became such an issue in 2010, like before 2010, when we were just on feature phones, the big deal was people calling and sending SMS text messages to push out of memory the amount of messages that were left. But in 2010, now we suddenly have smartphones on the scene, and we have actually BlackBerry was the first one to introduce some of the remote wipe features, and we have remote wipe capabilities that can be deployed against a device in case it is lost. It's a security feature, but it's not a security feature when a nefarious actor gets rolled up and has their partner in crime go ahead and send a remote wipe to the device in order to reduce evidence. Yep. So the reason this became prevalent at that time is it became more of a concern at that time, right? Because you're not just talking about, they pushed out the SMS messages. I can still get those potentially from CDRs. Now you're talking, like, at least the signal. Now you're talking complete loss of data. You're not getting anything. Whatever you can get from the ISPs, you can get from the ISPs, but the device, you're not getting nothing.
And I'd be really fascinated.
Potentially, obviously, 2010, we still had a lot of full disk recovery methods, and it wasn't full drop of encryption keys. So I understand all of the caveats and nuances to what I just said. So I retract the statement being an absolute. Sorry.
But I would love to study it today. That was, 3G beginnings of 4G. Now we've got 5G, 6Gs coming out. Cell phone antennas are much more advanced than they used to be. Yes,
but at the end of the day,
the Faraday bags, I don't know if they're keeping up.
Yeah, you need to test them.
And I don't know how you keep up with it. So I'd love to do that experiment again and try it with a whole new set of current generation phones, current generation Faraday cages, and see how they hold up. Because no one ever tested, and to this day, I don't know of any follow-up tests or no major tests. No one ever thought, hey, the manufacturer says that this works, but no one thought to actually go test it in the field and see if it worked. We all took them at the word.
Can we also talk about user errors with Faraday bags? So to be clear, there are some Faraday bags that have Velcro around the outside, and I've seen people place them in there and close them, and you have to use the pocket. If you don't use the pocket, the Velcro doesn't actually shield. The Velcro is the same thing with the roll-down bags. You have to place it in there and roll down correctly. So there is a lot of user error, but I'd say the biggest issue I've had with Faraday bags personally was people moving something out of the bag into the cage or into the Faraday box, and they literally take it out and transfer it, which is enough for the signal to get sent. You have to put the bag in the cage, close the cage, and that bag stays in there until your exam is done, until you've completed your image. So
my favorite is when they pigtail the power cable out of the Faraday bag and into an electrical outlet.
So nowadays we are very lucky because there are so many portable power banks and trickle chargers that you can put in your Faraday bag and connect without having anything. When you pigtail out of the bag, you're actually creating an antenna to your phone. So that cable that's now for your power actually serves as an antenna to the device. So that's it increases.
And they will take advantage of that.
And they will take advantage of it, especially if they know and see it. So you've done all this crazy cool research. You have a PhD in cyber forensics. You've been at MITRE conducting research and really changing the way a lot of organizations conduct forensics for over a decade. And as we were talking before the show, the whole topic of imposter syndrome came up. And it's not something we've really tackled on here. But, and I think part of it is I think it's such a common thing in our field. But you being as credentialed as you are, you mentioning that you do still deal with that, I thought it was really interesting. What do you do to overcome those moments? How do you deal with those moments when they creep in?
I try to remind myself that I do know what I'm talking about and that I've done the work. But more importantly, I remind myself, whatever I'm here to present on, whatever I'm talking about, whatever I'm doing, I'm doing my research and I'm being very thorough about it, even if it's in the moment. And that I have a right to come to the table and talk. And so even when I'm nervous, when I don't feel that when I don't 100% feel that I deserve to be where I'm at, which is very easy to do at MITRE, by the way, because everyone here is incredibly
There's brilliant
intelligent.
people at MITRE. Brilliant.
I do not always feel that I am the smartest person in the room just because I have a PhD. So do 10 other people.
So I think that's important, though, right? Like, you don't need to be the smartest person in the room to share, because we're all building on each other constantly. And I think the normalization that no matter where you are in your career, even if you're working at MITRE as a senior cybersecurity engineer with a PhD, that it is normal to feel that imposter syndrome. This is a normal feeling, but you know what? I think it makes you better. I think
and it's okay.
that I think it's okay because I think it forces you to make sure your assertions are right. I think it forces you to do the work and to continually improve, as long as you don't let it be debilitating, as long as you still share what you're learning.
Yep. And I had to, that can be a fine edge between like being perfect and knowing everything and being good enough to actually express it in a timely manner.
Yes.
That's a fine line, because perfection is definitely the enemy of good enough. And sometimes you have to move on a timeline.
And, deadlines help with that. Like, if you set yourself a goal that you're going to submit to some event, that you're going to write a paper for some conference, that you're going to share this result by this time, and sometimes your case itself demands it as a practitioner, but share what you've got at that time. And remember, it actually doesn't need to be perfect. Every single research paper I've ever read includes a further work section, right? Like what you would do with unlimited time, money, and knowledge, right?
Absolutely.
And a lot of times those things are followed up on by somebody else, and that's okay. We build on each other. So I guess it's important to remember that you can make that future work statement,
yep.
and that's okay.
Definitely can. And yeah, don't let it make you afraid of attempting something, of trying. No one learns anything if you don't try.
100%. Or sharing, right? You've got to get it out there. And I just love it. I love it. Thank you. I would
love to actually see, it's hard to make a sell for this, but I'd love to see a forensics journal dedicated to failed research. People who've tried something and it didn't work. Because if it doesn't get shared, somebody else is going to attempt to do the same thing. And someone else somewhere else is going to do the same thing again, because no one ever learned that this was not the right method, or that this particular stance didn't work.
That's really fascinating, Eric, right? Because we learn more. I don't like the word failure in there, right?
Yeah.
Like there's that whole statement, I don't know the number, but how many attempts did Thomas Edison make before he created the light bulb, right? There's going to be, but every single one of those is not a failure. It is learning what didn't work so you can get to what works. Just like in the models that you build when you're building AI models. Yep. I think that's so pertinent. Thank you for sharing that.
It became really poignant to me when I was working on my dissertation. I was like, I don't know if I'll get above a 50% average on any of my results. I don't know if this will function. But I still thought it would be important to publish it somewhere, even if that was the case, because then somebody would learn, hey, this is not the way to do this particular thing. Try something different.
I actually remember us having a conversation while you were working on your dissertation to that. You're like, I don't know if it's going to work, but it's still alerting. And I love that, right? Like that, yep. and it did work, which is fantastic.
Yeah.
So, Eric, what do you do when you're not doing digital forensics, when you're not coming up with new ways of testing things and doing things? What makes you tick outside of DFIR?
A lot of different things, but my latest hobby has been 3D printing. So, as a present to myself for graduating, I bought my first 3D printer, and I just kind of fell in love with making random things.
That's awesome. What kind of things you making?
A lot of miniatures and models, and then for Christmas I started getting into lithophanes. So I'll try to hold one up so that people can see it.
Oh wow, that is incredible!
I made little light boxes for my mom and sisters.
Oh my gosh, they're so detailed.
Yeah, I thought they were really cute, fun little keepsakes, and so.
I love that. That's such a personal, nifty gift and thought idea. I love that. What else are you making?
Well, it's kind of hard to see, so I'll move my camera, and I apologize to everybody. But during the summer and COVID, I got
oh my gosh!
And creative, and made a Star Wars diorama out of my office.
That is incredible.
And I constantly waited for security to come by and tell me that I'm not allowed to decorate my ceiling the whole time I was doing this.
I love that. That is incredible. You're definitely our first Cash Up guest to bring us to your ceiling to see your diorama that you've 3D printed. That is so cool and so, again, detailed. I love it.
It's been fun. I've always enjoyed painting the miniatures. I was a tabletop gamer.
I remember back in the day.
Graduating and getting back into it. And then COVID hit right after. I was like, oh, so now I'm at home and I have nothing to do.
That is
I don't have a dissertation to write anymore. So yeah, I started printing and I was like, I'll make this diorama. And
that is fantastic.
Continuous work in progress. It's going to continue to expand just because I can.
I love it. I love it. That is so awesome. So it's not complete yet.
Nope.
So you've had this really cool career to bring you to this point. And we have a lot of folks who are listening who are probably like, oh, does this mean I've got to like go to school and get a PhD to get into digital forensics or whatnot? I'd love to know what your advice is to folks interested in getting in DFIR. Thank you.
If you're interested in it, get into it. Whatever part of it is fascinating to you is fascinating to someone else too. And I guarantee you there is a blog somewhere. There are YouTube channels dedicated to whatever it is you're interested in. Look them up. And do not be afraid to contact the people who are creating it. They're creating it because they want somebody to talk to them about it. I want to publish my dissertation in a journal, not at a conference, not because I just want to see my name in print. I want to have discussions with people about it. I don't want my research to be useless, and nor does anybody else. We want you to take it. We want you to work from it. We want you to learn from it. And there's so much more out there now than when I started. And it's so much more accessible. YouTube is fantastic.
Really?
Magnet is producing fantastic videos.
Oh, thank you.
Like straight up, I mean, they didn't exist when I started. If I wanted to learn how anything worked, I had to get my hands on it and try. And there's a lot of free and open source material out there.
Absolutely.
Just play. Do you have to go to college for it? No. Will it hurt your career to have a degree in it? No. Like, it's always a good option, especially if you're, still young and trying to figure out what you want to do with your life. College is a great way to learn. I won't take it away. But if you've been on a career path and you want to switch suddenly, hey, there are plenty of people out there who are willing to help you out, mentor you, provide advice. Your guest a couple weeks ago mentioned This Week in Forensics.
Yes.
Like, find an article, look it up, and run with it. my best advice. Don't let anything hold you back. Don't let somebody say, oh, well, your hardware's not good enough. You know what? I
Oh,
did all my forensics on a Microsoft Surface for 7 years because that's the laptop I had when I was taking notes at college. And it worked perfectly fine. It could handle everything I needed it to handle. I didn't need 64 gigs of RAM and 4 graphics processors in order to run things. Like, you can make it work. Don't 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 be afraid, and don't let people say, "Oh, the technology will hold you back." It won't.
and you know what? To be honest, I think when you're scrappy and you're doing it with it forces you to actually understand things a little better, if that makes sense.
Oh, absolutely.
It forces you to get into the weeds and understand the fundamentals in ways that you wouldn't. And I love this concept of just find something that interests you, because there are so many different areas of our field, and go repeat a blog post, go repeat a study, go see if you can find the same thing, go see if you find something different on a different version. Like, what a great way to delve in. And 100%, like, contact the person who created it. People like to talk about the work they did because they want it to go further. Just like we were talking about, like, they may even tell you, here's the thing I didn't test that I wish I had time for, but other work and cases came up. And that might even just give you the impetus to have something for you to research, own, publish, and then that's your way in. Like,
Absolutely. One of my favorite things about going to I remember I won a student scholarship to Black Hat, which was a phenomenal conference and fun to go to. But one of my favorite things is I got to meet the people who wrote some of those articles that I was reading. And I straight up just would walk up to them and ask, like, hey, I'm Eric. I'm a PhD student at Purdue. I read this article and I kind of want to take it and do this. Can you help me, like, devise this experiment so we can see if this works the right way? And sure enough, they'd give me their phone number and be like, yeah, as soon as this conference is over, just give me a call. We'll figure out how to make this happen. And I know I feel that way. Like, if somebody came up to me in a conference and said, hey, I want to, like, run with your experiment. Can you help me set it up and do this? I'd be happy to. And I have to imagine everybody else would be too.
yes, no, I think you're 100% right. But it even goes to when I was doing your introduction and I mentioned how we met.
Yeah.
I literally heard you say your name, and I immediately, after that talk was over, like, ran up to you and was like, oh my gosh, I've read this work of yours. And we, like, sat there and discussed it. And that was incredible for me because I was referencing it. And I think it was great for you to just have someone to talk to about it.
Absolutely.
And that's exactly it. So don't be afraid. I think sometimes people are intimidated to talk to the person who presented the work. Read the work, understand the work, test the work, and then reach out to them. Like, they are going to love that. They're going to love that you tried it with a new version, or you tested it with different equipment, or you did something else, because you're never going to have the exact same scenario they did. Or maybe even you took their data and found something else in their data set. Like, that is awesome. You're going to love it. I love it. It's such a great piece of advice.
Yeah. And don't think you need a computer science degree, because I didn't get one. I didn't learn how to program computers, do computer programming, until well into my master's.
Oh, wow. Good for you.
Because I had such a bad experience early on.
You mentioned, yeah.
Now I wish I had more, and I'm teaching myself because now I'm fascinated and can do everything. Well, you don't have to be a computer science major. You don't have to understand how electrical circuits are built in order to do digital forensics.
1,000%. 1,000%. You don't. But one of the great things is you can work with diverse teams, with people who have different, for career switchers. You mentioned career switchers. You bring stuff we don't know you bring.
Yep.
Like diverse teams, like, you have so much value that you don't know you have that is valuable, because your experience allows you to look at the problem differently. And we're always looking at problems we never seen before. So I just love that.
Half my students when I was at Purdue in the graduate program were chemistry, physics, sociology, psychology, nothing with technology. But every one of them brought something to the table, and it was useful, and I loved their input.
That's so awesome.
Because, there's no such thing as something that's not useful in this field. And there's no reason to tell yourself you can't, because that wasn't where you started.
1,000%. Just Great advice. Thank you so much, Eric. Thank you so much for coming on today. This has been such a pleasure. I always love chatting
so
with
much
you.
Fun.
Thank you so much, everyone, for listening and for joining us today. We've got a great schedule still coming up. You can find it at magnetforensics.com/cash-up. Next week, we have Chad Tilbury, followed by Katie Nichols, Lexi Van Hoovel, Ali Hadi, Brian Hussey, Matt Mitchell, Ori Corbello, Steve Watson, and more. So we hope to see you next time. Thanks. Bye.